Hello and welcome to the course on software architecture. I'm Professor Shantanu Sarkar. A brief introduction about myself. I'm a professor at the Department of Computer Science, BITS Pilani KK Birla Goa campus. I have done my bachelor's, master's and PhD in computer science. Have nearly 20 years of experience in applied research, product and application development, consulting as well as teaching. So I have built products application myself. I have been an architect. My broad area of work is software engineering, and that's a pretty broad area, vast area. So on that, more specifically, I'm interested in software architecture as a research area, software design, the software modularity in terms of existing softwares, how they can be refactored, different software re-engineering techniques. These are the areas where I have worked extensively earlier. Right now my area of interest is software development challenges in cloud as well as heterogeneous computing platforms. How to build software for these platforms are my current research interests. So we will go to the course. About the course, the objective of this particular course is to study the software architecture. So here we will call as just architecture instead of software architecture all the time. So in this context, architecture and software architecture are really the same. In fact, more specifically what we will learn is what are the abstractions of the software, because software architecture is essentially useful only when you build really large scale software, not really toy applications. So when you are building large scale application, it is necessary to have an abstraction of software to understand about its characteristics, how to create software architecture, in fact how to represent software architecture. Then what are the different relationships between the entities that comprises of software architecture, how architectural principles are used during system analysis and design. Then another very important part is that how we study about the role of different patterns, architectural patterns in software design. We'll study about the applicability of various design patterns that some of you have already learned or at least have heard of. The applicability of design pattern in the context of software design. So these are the primary content of the course, and towards the end of the course I will talk about how software architecture is relevant, and in fact how software is architected for newer computing platform, more specifically cloud architecture. So what is the objective of this course? The objective of this course is to have really deep understanding of the software architecture. I expect that after this course you have a decent understanding of architecture. Very importantly, remove the misconceptions, because in my experience, and I'm sure if you are working in industry you have the same experience too, that people really don't understand the architecture, how to even design the architecture, how to describe it. So there is really a lack of understanding even today. So I hope that after this course some of these misconceptions should go away. Then we will understand the current state of discipline in software architecture. By current state I mean that what is in practice, what people are actually doing and how they are practicing. That's what we'll be learning, but not necessarily really more deep or research aspects of it, because this is not really a research kind of a course, but it's more of a the discipline that's being practiced. Then know the way in which the architecture can impact design. Very important, because architecture comes before design. So architecture definitely has a big role during software design. Understand various architectural styles, views. These are the terms that we will learn throughout the course. Importance of non-functional requirements or quality attributes of a system. This is also very, very important concept of software architecture. This needs to be studied in the context of architecture, how those non-functional requirements, NFR, NFA, so these are essentially defined, and how these are captured, how they are reasoned about. So these are some of the things that we need to learn as a part of software architecture course. Then apply the concept. Design new systems in principled ways using well understood architectural paradigms that we will cover in this course. Unfortunately, as a part of this course, we will not have a provision by which you will be basically building a new system and try it out as the course progresses. That will be outside the scope of this particular course. It will be primarily in that sense theoretical, and of course I will give examples, real examples, but it will not be possible to have hands-on session as a part of this course. And we will present concrete examples of actual system architecture. Then evaluate designs of existing software systems from architectural perspective. So, well, this technique we will not really teach in detail, that how to evaluate, but the hope is that after you learn software architecture and after you understand specifically the non-functional requirements, then you will have enough idea to evaluate a given system. If a system is given to you, you should be able to evaluate its quality from the quality attribute perspective. And the evaluation of architecture and in fact understanding those quality attributes are something that we will learn in detail there in this course. So I hope that you should be able to apply those concepts in evaluating an existing software system. In terms of the study material, there are a few textbooks that I will follow. The first one is the Len Bass et al. Software Architecture in Practice, 3rd edition is the one that I would recommend you to buy or use. There is a difference between the 2nd edition and the 3rd edition, and 3rd edition is more recent. It contains many recent topics, and that would be relevant for all of us, which is why I would strongly recommend that you basically take the 3rd edition, not the 2nd one. The 2nd book is by Bushman et al. On pattern-oriented software architecture, volume 1. It's a pretty old book, 1996, but it contains a catalog of various architectural patterns and catalog of various design patterns. So this book is good enough for architectural pattern, design pattern understanding, and this is a book that we'll be primarily following. In addition, there are good books that have come recently, and I would recommend that you actually buy this book or look at this book by R.N. Tyler et al. Software Architecture Foundations, Theory and Practice by John Wiley and Sons, 2009. So this is kind of quite recent. However, the book by Len Bass et al., the 3rd edition, is, I think it came sometime in 2012 or maybe 2011. So that way it contains more recent materials. However, R.N. Tyler et al. Software Architecture Foundations is a good book. Specifically, it is in fact it is more theoretical compared to software architecture book by Len Bass. So some of you who are interested in actually understanding more theory part of it, more formal aspects of software architecture. By formal, I mean it uses more mathematical notations, more modeling. So R.N. Tyler's book is towards that, but Len Bass's book is more towards practicing software architecture. So these are the two differences, which is why I chose the practicing aspects of it. However, R.N. Tyler's book is also good. Then the well-known book is Gamma et al. This book, I'm sure you have looked at it. This is basically the first book on object-oriented design patterns. And Bushman's book basically contains the content of the Gamma book. So you can have either Gamma et al. For design patterns, but you will not get architectural patterns. For architectural pattern, you need to really look at Bushman's book. So the lecture notes would be, the lectures are primarily total 18, roughly 18 lectures. I mean, it can vary. I have taken this course several times. Sometimes it becomes 17, 19, but roughly 17 to it's 18, and it is 16 plus 2 because we'll have a review session as a part of this course. There will be two exams. The first one is a midterm exam, and there is a final exam. There will be quizzes, 3 quizzes, and typically a midterm exam is a closed book exam, and final exam is typically an open book exam. Now, one of the expectations from my side, from the instructor side, is that the exam solutions or answers are expected to be really crisp, to the point, concise, and it is readable, because there will be many answer scripts that we need to correct, and then if the quality of the writing answers are really difficult to even comprehend, understand, then it becomes really difficult to evaluate. So expectation is that the answers should be really crisp and to the point. Let's look at the detailed schedule of this course. The first lecture, well, this is not the first lecture. This is basically really the introduction part of it. You can call it a 0 lecture. The first lecture is about the software architecture and its importance. Then in the second lecture, we'll talk about different perspectives of software architecture. We will introduce quality attributes, which is a very important part of software architecture. Then we will talk about some of the quality attributes in details, and in that context we will basically introduce a concept called architectural tactics, tactics by which these quality attributes are actually addressed. Specifically, we'll look at the quality attributes like availability, interoperability, modifiability, performance, security, and testability. There are of course many other quality attributes, but these are the most important quality attributes that we need to address. Therefore, we need to study these in real details. We will talk about object-oriented concepts and UML. Here there might be some overlap with your other courses. I know that as a part of the software engineering syllabus, OO concepts are taught in much more details. Here I'm just going to give a very high level overview just for the sake of completeness. This is not really a detailed course on OO concepts, so it's just for the sake of completeness. Very basic OO concepts will be given, and UML design will be introduced, not in detail, but again to the extent that's required to understand design patterns, architectural patterns, and for you to describe different designs later on. For that, UML will be introduced, and again, it is for the sake of completeness. We will talk about a rational unified process, RUP, only again from the point of view of architecture, not the process in detail. Then we'll talk about architectural styles, architectural patterns, what are the concepts of patterns, how many categories are there. That will first give an overview, and there will be architectural styles like layering, and most probably by this time it is a time to have a mid-semester test. So most probably this is a logical break that we basically introduce till patterns and layering, and then we take a break in terms of the mid-semester exam. Then in the second half we will talk about architectural styles or patterns in detail. We'll learn more patterns like blackboard, pipe and filter, broker architecture, interactive systems, model view controller, adaptable systems, and then we will switch to the design patterns. The design patterns, under that we will cover 3 types of design patterns, namely creational pattern, structural pattern, and the behavioral pattern. And under these categories we will learn most important patterns, not everything, because there are many patterns that exist. Not all are there in Gamma book, but after that there are many books that have come, and people have introduced many other patterns. So we are not going to cover each and every one, but at least the basic foundation. So without which really one cannot really even understand design pattern in details, which is why this fundamental basic set of design patterns are required to be understood. Under creational category we will learn about factory patterns, factory methods. Under structural category we will learn about adapter patterns, decorator patterns, proxy patterns, composite patterns. Under the behavioral category we will learn observer pattern, iterators, strategy, visitor pattern, command pattern. And then towards the end, what we will do is we will then look at the new paradigm that I was saying, which is cloud computing. And under cloud computing we will learn things like what is a cloud computing at a very high level, and whatever level that's required for you to understand the architectural challenges of cloud computing. So after that we will introduce again, we will revisit in fact different quality attributes that are meaningful for cloud computing paradigm and how they should be addressed. How as an architect you should basically be concerned about those quality attributes when you're building software for the cloud, and various constraints, new possibilities. So this is how I'm going to end this course by talking about architecture for the cloud, and then there will be the NSEM, and in the NSEM the syllabus will be it will cover the entire book, right from the definition of architecture till the cloud. So whatever has been taught before mid-sem and till end-sem altogether will be the syllabus for comprehensive exam, and it's going to be open book. So thank you for listening. In the next module we will start with software architecture.